Okay, how's everybody doing today? All right, good. I see some familiar faces. My name's Tom Valine. I work at Salesforce, Director of Infrastructure Engineering over there. I'm here with Bhinav, Sura today, and we're going to talk to you a little bit about production monitoring at Salesforce, specifically a tool that we've written in open source called Argus. Okay, so what is Argus? For anybody who's had to do time as a site reliability engineer or doing monitoring or data analysis for service running in production, you may be familiar with the concept of time series, alarming, alerting. That's essentially what Argus is. Argus is a tool that we've written that allows you to examine time series data and discrete events associated with that. A couple of the features here. We have inbuilt service protection. So at Salesforce, one of our core tenets is multi-tenancy. And so Argus is a multi-tenant system, and being that it is, we actually have a mechanism by which you can apply policies to the usage of Argus based on either a single user or a group of users that restrict or enforce policies about how that user interacts with Argus. So if you wanted to restrict a group of users from, say, site reliability from pushing only a certain amount of time series data points per hour or per minute, you can do that. So some of the things that you can protect against is the rate of ingest for data, the number of alerts that are scheduled and executed per unit time, things of that nature. We have integrated alerting as well, so oftentimes it's not just enough to examine time series or operational data, but you may want to also be notified when something interesting occurs and hopefully be able to intervene before anything serious takes place, especially if it's something that's imminent that has not yet occurred. We have flexible dashboarding. So one of the things that we tried to do with Argus is that we wanted to get out of users' ways as far as dashboarding and give them the opportunity to write and build dashboards the way that they like to see them. This is something that's very personal for people. People like to see their data in different ways, in different formats. And so that was something that we had as a feature from the start. Everything that you see with Argus is available fully through the REST API. We built it API first. It's very high throughput, very low latency. We have a pretty small discrete unit of scale, so it does scale out very, very nicely. And it's typically used for these types of roles within an enterprise. So teams like capacity planning, search, maybe you have product feature teams that are interested in the performance of a particular feature, release over release, site reliability, and if you have a customer success platform that monitors the particular customers or organizations. Okay, but why another monitoring system, right? I mean, there seems to be so many out there. Here's just an example. All of them are excellent time series and alerting tools. A lot of people have probably used Graphite. OpenTSDB is kind of ubiquitous with time series data, Influx, Kairos. The reason that we built Argus is that specifically there are so many of these technologies, and the technology changes so frequently as new innovation arrives. What we wanted to do at Salesforce is we wanted to insulate all of our enterprise users from the thrash of that change. We built Argus in a way that we can retarget any of our core services to new technology relatively easily, but not only easily, but with very little disruption to the users. Argus provides an abstraction layer between our users and the underlying technology that we select. Obviously, performance is a big deal for us. Salesforce is a very large enterprise, and we have a lot of operational data that we need to look at, and we need to look at it in a very performant manner. At Salesforce, trust is our number one value, right? So customer trust is really big. We built in features like Warden, the service protection, not only to protect the availability of the service, but to provide a capability for doing forensic auditing, analysis of usage, and a variety of other things that would help support a trust story for our customers. Programmatic access for everything. We already talked a little bit about multi-tenancy. And the last 2 points are kind of core features that are really relevant. Correlation with non-time series data. So maybe you have discrete events that are generated from your release mechanism about when releases get rolled out. And your performance team wants to see if there's a regression based on a release. Being able to correlate the timing of those releases with your time series data, or correlating your time series data with your log data, is something that's very valuable. It's a primary use case for us, being able to drill in very quickly to not only the time series data, but all of the data that supports an investigation. It's highly dimensional as well, right? So we have a lot of operational data coming in, and it could be associated with a variety of different dimensions, maybe data center or host or the feature that the metric was emitted from. All of these reasons are why we decided to build Argus, because a lot of these weren't explicitly addressed in the existing tools that are available today. Okay, so if you've used something like OpenTSDB, I'm just going to go over a little bit of description of the features. I won't go into too much detail because I want to give Bhinav an opportunity to dive into some technical detail as well. But some things that you may notice here with our query grammar is that we actually introduce a couple of additional fields here. So one of them specifically is the namespace field. So being a multi-tenant system, there could be multiple feature teams that have commonly or similarly named metrics, right? And you want to prevent naming collisions between those metrics. So we have this concept of namespace, which avoids that naming collision, and it also forces write authority. So if you're a member of that namespace, you have permission to write metric data to that namespace, and it prevents other people from writing data into that namespace. We have the concept of a scope, which is just a logical categorization for metrics. And then we have the more common fields as well, which is the metric name, tags for dimensionality, aggregation, and downsampling. The bottom grammar is a grammar for our events. Similar, but a little bit different. Still, we have the namespace and the scope. We also have an event name, any number of tags that you want to apply to it, and then we have an event type that you can specify. This is just a user-defined field that you can use to categorize events, like release events or host lifecycle events, what have you. In Argus, events are associated with the user, so you can also filter events by the user that published them. So one thing that's a little bit different between Argus and something like OpenTSDB is that OpenTSDB, the events are actually associated with the time series that they're published to, right? Argus is a little bit different in the sense that the time series and the event data are totally separate, discrete from each other. So what this allows you to do is that if you have, say, release events that you wanted to display over 20 different metrics overlaid, you can do that quite easily in Argus, right? You can see an overlay of events with any number of discrete time series that you wanted to, which is really helpful for something like an SRE dashboard or customer success dashboard, where they want to go and look and see all of the metrics that are associated with that event and see if there is an anomaly or regression associated with them. In Argus, you can also store multiple events at a single timestamp. So say as part of a release, you have a bunch of release subsystems that generate events at exactly the same timestamp, and you wanted to store all of those and be able to recall them. You can do that with Argus. Other time series systems only allow you to store a single event at a timestamp. We talked a little bit about event categories, the event types, and the fact that they're available per user. So on this slide here, you just kind of see an example of what I was talking about, being able to overlay events over different time series. So if you look at this, this is actually the same event. This was an event, I believe, that was generated from one of the Argus alerts. And it's just an example of that. We've overlaid that event over two completely different time series. And you can picture on an SRE dashboard or something like that where you have 20 different time series, and you see that same event all the way aligned in time across that dashboard. Alerting, so we have batch-based alerting integrated. It's a cron format. We have a couple of cool features. We can alert on missing data. We have single-ended and range comparisons. We have this concept of inertia or hysteresis, where the triggering event must occur for at least that duration before it's considered to be triggered, which helps to reduce the occurrence of noisy alerts. That's a typical problem that we've experienced. And also, you can put the notifications for an alert on cooldown. So even though, say you have an alert that triggers an event and a notification gets sent out, you can put that notification on cooldown for 12 hours, 24 hours, or, I don't know, 30 days if you wanted to. And even though the notification is on cooldown, the alert triggering is still being evaluated and being recorded. So even if you get a triggering event and the notification is suppressed, you'll still get a record of that in the alert history as well. The way that our alerting model works is that you can have any number of triggers and any number of notifications and have a many-to-many mapping between them. So it's really easy to build an escalation chain for your alert mechanism. And we also support a pretty robust notification interface. So currently, we support things like email and our operations center, Salesforce chatter. If you have an external tool like PagerDuty, we can support that as well. But if you wanted to integrate something like HipChat or something else, you can definitely just extend that notifier interface and get the support for that. One of the cool things about alerts is that with the events in Argus, when an alert is triggered, you can actually have that alert write an event back to a discrete data set, and then it becomes available to view as you would any other event. So if you have, if you're monitoring for a particular occurrence of some case and you get a trigger, you can write an event and then view that event across any other metric that you'd want to look at. So this is just an example of Warden. We kind of talked about it a little bit. It's policy-driven. It's applied per user. It applies at both the application level, at the Argus level, and at the subsystem level. So you can suspend somebody from pushing data, Timeseries data, but still allow them to do alert evaluation, or still allow them access to the read API. But it's also applied at both the subsystem and application level. So if somebody is just hovering below the line as far as infraction counts for a given policy, we also examine the total number of, or the total usage across all subsystems as well. And it could be such that the user is performing operations in Argus that don't quite generate an alarm for any particular subsystem, but in aggregate, they're abusing the system, and we can actually suspend users based on that information as well. It's progressively punitive, and it's configurable, so you can suspend a user for 5 minutes, an hour, 24 hours, and eventually even indefinitely suspend them from the system, which would require an administrator to go and reinstate that user's account. And it's customizable. So this is just an example of an Argus dashboard, or a chart that was pulled from a dashboard that just shows the number of data points per user that was posted. And also, these alert flags are indications of Warden events where somebody was suspended as well. So again, going back to the forensic auditing and the audit trail capabilities, you have all of this information about who is using the system, who is pushing data, who is pulling data out of the system. Custom dashboarding. So if users are familiar with a tool like Elk or Splunk that has a markup-based dashboard definition language, Argus is similar to it, but it's a little bit different. So we allow you to write general HTML markup for a dashboard. You can use facilities like Twitter Bootstrap to define your layout. You can have multi-grid, multi-column, or any combination of those. And we provide you custom HTML tags where you can go and insert graphs, right? Insert controls to parameterize your dashboard. So say you have a dashboard for data center health, you can add a control in there that selects the data center that you want to examine. Those input controls are actually fed into the query. So here on line 16, it may be a little bit hard to read on this slide, there's this AG metric tag, and you can see that there's this dollar syntax in there. Those are placeholders for those control values that are then substituted into the query to fetch the correct data for the configuration that you're examining. So it's pretty flexible, right? And we really wanted to empower the users. Like I said, dashboarding is something that's very personal, and everybody likes to look at data their own way. We feel that with Argus that people get a chance to really build their own dashboards in the way that they like to see their data. Up in the upper left, you have an example of a couple of different charting types: stacked area chart, line chart. There's a variety of different chart types in Argus as well. As I mentioned before, we have a full REST API. We designed Argus API first. So any functionality that you can do through the UI, by definition, exists in the API. That includes just a pure data ingress and egress, management functionality, policy definition for Warden. Everything that you can do with Argus is done through the UI. It is authenticated, so we have an extensible authentication interface. I think by default it ships with LDAP integration, but the model is pretty simple. You log in through an API call, you do stuff, and then you log out. Again, we still get that audit trail capability for people that are performing actions within Argus. And we understand that since data analysis is such a personal thing for a lot of people, right, we wanted to build an API and just get out of users' way. Perhaps you don't even want to use the UI at all, but maybe you want to take this data and feed it into a third-party system or a legacy system, or write clients directly against it to manipulate that data. People have done all of those things with Argus already, within and without of Salesforce. We have a client that can integrate with Splunk, where you can go and scrape metrics from your Splunk log files and push those metrics directly into Argus. Similarly with events as well. Argus Poke is a tool that was written to just automate the generation of dashboards and alerts, and a dashboard creation tool for provisioning new hardware that automatically provisions new dashboards as well. So all of this stuff is just interacts with Argus directly through its REST APIs, and none of these use cases use the UI at all. Okay, so how does it work? This is just a description of the service stack here. Up at the top, we have obviously the web UI. We do have custom apps that are written over the top of the API, and any other clients that are using the API. It's fronted by web services, and then this is just a broad description of the types of microservices that exist within Argus. So things like namespacing, scheduling, which is used for alerting, wildcard expansion, caching, and then at the bottom layer are the enterprise resources that we use to support it, which includes authentication, ORM, messaging, and of course the Timeseries engine that you select. Okay, but how does it really work? Okay, so this is kind of a better topological description or visualization of how Argus actually works. So in the top row, you see our basic unit of scale, right? So we have a UI tier backed by web services, and within those web services, we have an API client, which we call Argus Core. That interacts with the other units of scale in that top row through the message bus, and also with these clients that are down above the enterprise resource layer. Everything that happens in Argus is done asynchronously and is decoupled from the actual web service endpoints. These clients are provisioned as many as you want or as little as you want, and they perform asynchronous operations for evaluating alerts, for draining metrics out of the metric queue into persistent storage, sending notification, a variety of different tasks. And then down below, again, we have the enterprise resources. By default, we use Kafka for our message queue. We use HBase and OpenTSDB for our engines. But we also have an implementation of Phoenix over HBase, which Bhinav is going to talk about. And I think we may have one for Kudu as well. This is how it's going to evolve going forward. We're going to break up that performance bottleneck in the message queue layer and the enterprise resource layer. by adding a routing layer to do fork join and splitting up queries, fracturing them, sending them out, and then reassembling a response back. And so that's a brief description about the features and kind of what Argus is about. I'm going to hand it over to Bhinav, and he's going to talk a little bit more about the data flows and some of the technical aspects of it.
Hey, guys. Hello? OK. So thank you, Tom. My name is Bhinav Sura, and I am a developer with the infrastructure engineering org at Salesforce. Spend most of my time working on Argus and working at the platform layer of Argus. So that last slide looked really cool, man. You had all the HBase components broken down and fork and join on top of it. So that looked cool. But for now, let's go through a typical alert evaluation data flow and how that works in Argus. So once a user creates an alert, it's persisted onto RDBMS, and then Argus has an internal scheduler that runs every 10 minutes, grabs all the alerts that have been enabled, picks them up, and then pushes them onto the cron scheduler that we internally use. As Tom had mentioned, alerts are evaluated based on the cron expression that you give them. So if the cron expression has been satisfied for a particular alert, the scheduler will schedule it onto the alert queue. We use Kafka for that. And then on the other side of it, we have an army of alert clients that are just continuously polling the alert queue, waiting for the alerts that have been scheduled. And then each client performs an evaluation task. And the evaluation task is nothing but grab the data from the persistent TSDB layer, evaluate if the the threshold has been met for that data set, and notify the user if it has been, or back annotate, or do whatever the alert has been defined to do. So that's a typical alert evaluation data flow. We remove the bottleneck by having an army of alert clients that can continuously poll the queue and grab alerts asynchronously or parallelly, and make sure that the queue there's not much lag on the queue. So yeah, the alert client dequeues from the alert queue, triggers evaluated, notifications, and cooldowns updated. Yep, that's a typical alert evaluation data flow. So moving on, we have the metric and event data flows. So metrics and events, both of them, the writes for both of them are asynchronous, meaning that when someone posts a metric or when someone does a post to either the metric endpoint or the event endpoint, the web server first writes them to the queue. And then again, we have an army of metric commit clients and event commit clients that asynchronously poll the queue and persist it to the persistent storage. So we use Kafka for scalability. We initially started off with ActiveMQ, and there were some scalability issues with that. So we moved on to Kafka, and has been performing really well for us. As far as the queue is concerned, we have separate topics, each for metric, events, and alerts. There's something special with the Argus, especially with the Argus metric queue, in the sense that it is consumed by two different types of clients. One of them is the metric commit client that I already mentioned, that it polls the queue, dequeues all the metrics, and then commits them to the persistent TSDB storage. The other type of client is a little special. It's called a schema commit client. So Argus, and I'll talk about this in some of the future slides, but Argus needs, or users need to discover metrics in Argus, or if they want to have a wildcarded query in Argus. So Argus stores all the metadata about the metrics in HBase, and schema commit client is the one that actually commits all the metadata about different metrics and stores them on HBase. So I'll talk about the discovery service and the schema service and the client in a little more detail in some of the next slides. Okay, so let's go through the TSDB service, or the first initial TSDB service implementation that we had for Argus, the OpenTSDB service the OpenTSDB implementation. So we all know it uses HBase underneath. Row key is pretty standard. It's metric UID followed by timestamp followed by one or more tags. The good thing with this row key design is that if you know the complete metric name, then it's pretty fast to narrow down the search space and return the required data set. It actually stores all the time series values on hourly boundaries. So uses encoding based on the timestamp of the starting hour, and then returns you the data set by calculating the difference between all the data points within that hour and the start hour. So some of the pros of OpenTSDB are that, as I mentioned, it is extremely fast when you query using the entire metric name. So if you know what the metric name looks like and you query that, no matter if you're providing it a tag or you're skipping the tags, it's very fast. Another good point with OpenTSDB is that with one write daemon, it gives us a throughput of around 5 million data points a minute. That's pretty good. And then some of the cons that we have especially faced with OpenTSDB are the tag card. They revolve around tag cardinality. So the one is that it puts a hard limit on the total number of tags that you can have with the version of OpenTSDB that we use, and it's limited to 8. And as Tom had mentioned, that customers or internal customers at Salesforce, they sometimes need a much more higher dimensional data. So that becomes an issue if people want to have more than 8 tags. Another problem with tag cardinality is that as the product of distinct tag values across all the tag keys for a particular metric increases, the performance decreases drastically. And this actually happened with us, where we had one tag key which had at least a few 100,000 distinct values, and the performance was really bad. Another small or minor concern with OpenTSDB is the UID exhaustion problem, where if you use the default build of OpenTSDB, it ships in with a 3-byte UID for each for metric, tag key, and tag values. So that allows you to have only 16 million unique metrics, tag keys, and tag values. We kind of had a workaround this problem by using by categorizing metrics within a scope. So the way we do it is scope in Argus internally becomes a metric in OpenTSDB, and then the metric name in Argus becomes a metric tag in OpenTSDB. So that was just some workaround to in order so that we don't exhaust the UID space pretty quickly. Okay. So the next version of or the next implementation of the TSDB service that we have is the Phoenix TSDB service, and thanks to James, he and his team, they helped out for that. So Phoenix uses a HBase underneath. The row key looks more or less similar to the OpenTSDB row key. Again, it is prefixed with a metric UID that helps in making in retrieving point queries or retrieving data with point queries pretty fast. Each scope metric combination in Argus is modeled as a view in Phoenix. So that and another good thing with that is the schema is managed outside of the data. So what that means is each Phoenix view name is stored as, or there is a corresponding row for each Phoenix view name in the system catalog table of HBase. So that if when I would talk about discovery service and schema service, if you want to introspect the schema, you know want to discover metrics, you want to discover scope, that can be really helpful. It also supports secondary indexes, and so if you want to have a metric index table, then that would be really fast for discovering metrics versus scopes. So one of the advantages of using Phoenix over OpenTSDB is that Phoenix pushes the computation down to the region servers. So what that means is, let's say I'm trying to aggregate data across different hosts. Then in that case, OpenTSDB retrieves the data for all those different devices and aggregates it at the client. Versus in Phoenix, it pushes it down to the region servers. The region servers perform the aggregation and return a much more smaller data set, so which also conserves the network bandwidth. So a couple of good points there. The aggregation happens in parallel, and B, the network latency is reduced because the amount of data that is being shipped over network is pretty small. It also allows skip scan filter optimization for minimizing the data scan. It uses guideposts to do that. And another good thing or another advantage of Phoenix is that leverages row timestamp optimization for filtering H files. From our preliminary performance tests, what we have observed so far is it performs on par with OpenTSDB if the aggregation is or if the amount of aggregation to be done is tiny or small, and in that case, both OpenTSDB and Phoenix, they perform pretty well. The one advantage of Phoenix in terms of latency, read latency over OpenTSDB is when the aggregation size is pretty huge. So let's say if I'm aggregating across a tag which has hundreds of thousands of distinct unique values, then that kind of aggregation would be faster in Phoenix versus OpenTSDB. And for the above mentioned reasons, because it pushes the computation down to the region servers and conserves network bandwidth. So some of the future work that can be done with Phoenix TSDB service is it can be used to perform joins against other Phoenix tables. And in longer term, we could also leverage DrillX, which is Apache Drill over Phoenix for cross-cluster queries and joins to other non-HBase data sources. So yeah, here we are at the schema service. So why do we need a schema service, and what's the motivation behind it? So there are two main use cases why we need to store additional metadata or metadata in addition to the data points or the metrics that we already store. So A is, or number one is, I want to discover what metrics or what scopes exist in Argus. It helps us answer some of the questions here. So what all metrics exist within a given scope? What all distinct tag values exist for a given tag key? And some of the other more complex questions. The other motivation for having a schema service is to support non-wildcard queries, or support wildcard queries, I'm sorry. A non-wildcard query, for example, would look like you would specify the exact query without using any wildcards or regexes. But a wildcard query, for example, would be I want to look at all the I want to look at all the pods within my data center. I want to look at devices that match this regex, et cetera, et cetera. So what we do is internally when someone queries Argus with a wildcard query, it is expanded into a set of non-wildcard queries using the schema service, using the discovery service, which internally uses the schema service, and then we query the persistent TSDB storage for each of those queries. So the implementation, we use HBase to store all the metadata for metrics. Each record is nothing. It's plain simple. It's a denormalized version of the metric, and each metric in Argus has namespace, scope, metric name, tag key, and tag value. The data points are stripped off because there's no need for data points. It's just the metadata that we are interested in. In order to have efficient queries or in order to increase performance for different types of queries, we index it in two different ways on two different tables. So one is the metric index table. The only difference between the two tables is the positioning of the different entities or the different entities of that schema record. So in the metric index table, it's the metric name that is prefixed, whereas in case of the schema index table, it is the scope index table. It is scope that is the leading part of the row key. Depending on what the type of query is, we make a decision whether we should be querying the metric index table or the scope index table. The one con with that is we are actually duplicating storage because we are storing the same information across two different tables. The discovery service internally uses Schema Service to query all the metadata and expand wildcard queries into non-wildcard queries, as I had mentioned earlier. What you can also do is it provides an ability to filter records by type. So you can say, oh, I want to get all, or I want to query all metrics that match this regex, or I want to query all scopes that exist within Argus. And so it just gives an ability to filter records by type. Caching. So some of the queries with Argus, some of the read performance was really slow, especially if the query span or the time window span for a query was greater than 24 hours or was greater than X number of days. So we decided to have a cache service or a cache TSDB service that would perform query level caching. So what it does is given a metric query, it reads it tries to read all except the last 1 hour of data from the cache. If it's a no hit, it obviously goes to the persistent storage and gets all the data, stores it in the cache. But if it's either a partial hit or a complete hit, it gets all that data, gets the remaining data from the persistent storage and returns it back to the client. So we have configured it such that it expires in an hour. Because we felt that getting the last 1 hour of data from the persistent storage was quick enough, but that can be configured to extend to either a day or 5 days, depending on what performance you get out of your TSDB engine. We also have a cached discovery service which caches the results of results of a wildcard query. So the key would be a wildcard query, and the value for that cache entry would be a list of all the expanded non-wildcard queries. The cache expiry time for that is a day, since the wildcard expansion doesn't really change that much. Okay, so more information you can find Argus project on GitHub. Go ahead and take a look at it. We are still in, or the wiki is still in progress. We're trying to get as much documentation out there as possible. Thanks a lot to all the team members that have helped on the project. We have some of the team members here. Kudos to them. And that's it.